Hey, hello everyone. Today we're going to go through another paper. So we're going to be doing the full solution to this paper. It's the October-November 2023. This is for Pure Math 2 and the code or the zone is 2-1. Let's jump right into it. Okay, so our first question says, it is given that theta is an acute angle in degrees, such that sine theta is equal to 2/3. Find the exact value of sine theta plus 60. Okay, so we see here they want exact values, so they don't want any degrees or rounding off. They've also given us what sine theta is. Whenever I see something like that, my immediate thoughts is to start just drawing up a triangle. If I was to label that theta, sine is opposite over hypotenuse. So when we draw up a triangle like this, we already know our one ratio. So according to where I've put theta here, we know that sine is the opposite of the hypotenuse. And so therefore we can find out our other length. I'm just going to call it x. And that's going to be 3 squared minus 2 squared. Okay, so this is going to be root 5. So if we needed another ratio, for example, cos, which we're probably going to use, we can see here that cos theta is root 5/3. Okay, so that's the first thing to do with this piece of information. You can get other information from there. If we needed tan as well, you could just read tan off of the graph. So just remember that that's always a tool that you can use with respect to or with regards to these trig ratios. Okay, so now it says find the exact value of this. I've got a theta and I've got a 60, and this is a compound angle. So I've just got a little bit of my MF19 that I've taken a shot of, and I'll put it next to me here. We're going to be using the sine compound angle. So go and make sure you've printed out an MF19 and you've got that handy with you. Okay, so if we expand this, we have sine theta cos 60 plus cos theta sine 60. And I hope you can see now where my sine theta and my cos theta are going to be coming in. So sine theta is 2/3. And then cos 60, so this is your special triangles, but you can just work this out on your calculator as well. So cos of 60 is root 3/2. And then in this case, cos of theta is root 5/3, and sine 60. I'm seeing here sine 60 is root 3/2, sorry, and cos of 60 is actually 1/2. Okay, so just make sure that you do get those correct. Use your calculator if need be. You don't have to do that with a special triangle. And here I have a third plus. We've got a root 15/6. And that is my final answer for that one. So you don't actually need a calculator, but you can do some values. Just make sure that you don't give this answer in decimals, because they are asking for an exact value. All right, jumping right into question number 2. They say a curve has an equation, and then they've got 3 tan half x times cos 2x. So here we've basically got two functions multiplied by each other. Okay, find the gradient of the curve at this specific point. So we need to find dy dx, where x is pi/3. Right, so immediately when I see two functions that are multiplied by each other, I know that I need to be using the product rule for differentiation. So once again, make sure you have your MF19 on you, and you can use the product rule. I don't personally use a product rule. I just do the shortcut, but it's exactly the same thing. So if we take a look, I'm just going to rewrite this. Okay, in this case, you would want your one function to be u and the other one to be v, and then you differentiate them separately and then put them together with a formula. That is the same as saying So what I'm going to do is I'm first going to differentiate my first function. So 3 tan half x. So if we look at tan, the derivative of tan is sec squared. It's going to be 3 sec squared. And then I keep my inner function. But using the chain rule, I need to make sure I also multiply by my inner function. Okay. So derive the first, leave the second, and then plus, leave the first, and then derive the second. So now I need to derive my cos. My cos goes to minus sine. Once again, we've got a function inside the function, so I also need to use my chain rule. Okay, so I'm just going to simplify this now. It's going to be 3 over 2 sec squared of a half x equals 2x plus, and then here I've got a minus 6, so I could actually take away the plus. It's going to be minus 6 tan a half x sine 2x. Okay, ideally you wouldn't have your MF19 stuck on the side, so you could hopefully just write this all in one row. What we're going to do now is we want the gradient at that specific point. So I'm now going to plug in my x coordinate. This is a half over 3. Okay, let's just take a look. They did not ask find the gradient of the curve, so they're not asking for exact values. So let's just see what this ends up being. I'm gonna, I think I'm gonna simplify where I can, and where I can't, I'm just gonna plug it into my calculator. So this is cos 2 pi over 3, and then this is going to be cos squared pi over 6. Okay, so I'm first actually just rewriting this. Okay, make sure your calculator is in radians because we've got a lot of pi's here that we're working with. Okay. Okay, cos 2 pi over 3 is minus a half. And then cos of 6. And then everything squared is 3 over 4. And we've got 6. And root 3 over 3. And then sine of 2 pi. Sine of 2 pi over 3 is root 3 over 2. This is going to leave us with minus 1, minus 3, and a final gradient of minus 4. Okay, did we answer the questions? The gradient of the curve at that point. So we found the derivative, we plugged in the point, and we have our gradient. All right, let's take a look at the next question. So find the integral. Okay, we're going to integrate. We're going to give your answer in the form of lim a, where a is an integer. Okay, so it can't be a fraction or anything like that. Here we're going to be diving into integration. If I just look at this type of integral, here we have our parent function, so it's the reciprocal function, and the integral of that is lim x. So this is quite a straightforward question. Is a definite integral. What we need to remember is we don't just have 1 over x, but we've got a function within the function. So we just need to make sure that we use our reverse chain rule. Okay, I'm going to keep my coefficient, then I'm going to integrate, and I'm going to keep my inner function, and then all of that should be divided by 2. I've actually integrated directly, so I need to take my integral sign away, and then that's going from 10 to 4. Can I simplify this? Yes, I can. Just going to say 2 ln minus 5. Now I get to plug in my 10. And that's going to be 15 minus 2 ln 3. Okay. For both of these, they're both actually positive, so the mods kind of fall away, and I can bring up my square. I can combine these now. Just using my ln rules. Then I'm going to do 15 squared divided by 9 is 25. So my final answer for this question is ln 25. All right, let's jump right into part B. So here it says find the exact value of, and then we're doing another integral. We're also going between 4 and 10, but in this case we have an e, an exponential function. Okay, there's not really a link between the two, so it's just they're testing our ln integration, and here they're testing the integral of e. We know that when we integrate e, it's the only one that stays exactly the same, so it's going to remain the same, but because we've got a function inside of it, we need to make sure we do the reverse chain rule. So I'm going to integrate immediately. I'm just going to leave it as it is, that's the integral, and then divide by the coefficient of x. All right, that is basically the same as saying a half e to the 2x minus 5 between 3 and 4. I'm just going to plug this in immediately, 20 minus 5, and then 8 minus 5, which is going to leave us so a half e to the 15 minus a half e to the 3, and they did ask us for the exact value, so they don't want any decimals, and we can leave it exactly like that. All right, let's jump right into the next question. Here we have some mods, and we need to be sketching. So sketch on the same graph. We've got a mod function, and then we've got a straight line. So always just make sure, I've seen many students who will do a mod for both of these. Only one of them is a mod, and the other one is a straight line. Okay, when you're drawing your graphs, just make sure you label your axes. It's a good place to start. If we start, maybe we can start with our straight line. So we've got a gradient of 2 and a y-intercept of 7. Okay, so you don't need to be very specific, but do show where your intercepts are. If I want to find my x-intercept, I'm going to make y equal to 0. So x is going to be negative 7 over 2. So it's going to be somewhere over here. And that's going to be our straight line. Okay, just approximately. Okay, we can show that that goes on. And then we've got our mod. So the easiest way that I find my x-axis is I make 3x minus 5 equal to 0. So my new axis is going to be 5 over 3. And that is the same as about 1.6. So I'm going to put it over there. Okay, so now I've got my V shape that's going to be going from that point. If my x is 0, my mod or my y-intercept is going to be 5. So that's the easiest way that I find to draw these. And then we know it's a V shape, so it needs to look kind of symmetrical. What you need to do is you need to show your intercepts. So in this case, it's 5 over 3, and that's going to be minus 7 over 2, which is 3.5. So just bear in mind kind of that you should show the intercepts. If I were to draw this a bit neater, I would have my y like that, x like that, and then maybe just this calculating could be a little bit more to the side so it doesn't interfere with our diagram. Okay, right. Now, solve the equation, and what we're looking for is where does the straight line hit the mod? So you can see if we just take a look at this, we expect there to be an answer somewhere around here. And then if this was extended, the gradient of our straight line is less than the gradient of our mod. So we do expect these to meet somewhere up there, and that will give us another x-intercept. Okay, so it's just good to have an idea. We're expecting two answers. So let's see if we can find them. So I'm going to say my 3x minus 5 is equal to, and then you either pick the negative value, or 3x minus 5 is equal to the positive value. So what are these two values? X is equal to 12. That's going to be minus 2 over 5. Okay, minus 2 over 5. Does that look correct? And then does 12 seem correct? So if I just take a look at my diagram, 2 over 5 is about 0.4. Okay, so that is possible if I drew mine a little bit more accurately. And then a value of 12, we said they're going to be intersecting somewhere up here. So that also makes sense. That would be 12. Okay, so those are my values. So whenever you're asked to draw a graph and calculate, just make sure that your answers make sense. Okay, there are more than one ways to do these mod functions. So another way to do it is to square both sides. You must just always make sure that all of your answers are valid when doing these calculations. Okay, let's look at the next one. So it says hence solve. Okay, hence means we're going to use what we just did. So that means we should look out for what is similar between the two. So if I take a look, I'm comparing here my 2x plus 7, and here I've got a 2 and then y to the 3 to the power of y plus 7. So can you see that it makes sense that x is equal to 3y in this case? And then I just want to make sure, is that exactly true? So here we've got our 3 times x, and this just looks a little bit different over here, but we need to remember that we can break this up. This is the same as saying 3 to the power of y multiplied by 3 to the power of 1. In other words, 3 times 3y, and if we were to say that x is 3y, that would be the same as 3, sorry, not 3 to the power of x, but 3x. Okay, so just make sure that you can completely relate these two questions, and what we can see is that x is equal to 3 to the power of y, so then I can use my answers from before. So instead of saying x, I'm going to say 3 to the power of y is minus 2 over 5, or 3 to the power of y is equal to 12. Right, to bring my y's down, I'm going to use my ln, but I can already see I've got a problem here because this is a ln of a negative number. So there's no solutions for that particular expression or equation. Here, 12, there is an expression. So here we've got ln 12 divided by ln 3, and that gives us a value of 2.26, and they said give your answer correct to 3 significant figures, and so that will be our final answer. Okay, and there's no other solution, just that one. All right. Let's jump right into question 5. So they say here, immediately I can see we're looking at polynomials. So this is our second chapter in our syllabus. Actually, sorry, this is our first chapter, but so under algebra, you've got modulus and you've got polynomials and the remainder factor theorem. So this is what we're looking at now. So polynomial is defined by that. So we've got a polynomial, but there are a's and b's involved. Okay, a's and b's are constant. It is given that x plus 2 is a factor. So that means if I plug in x is equal to minus 2, my answer should be 0. and that the remainder is 11 when it's divided by x plus 1. So if I plug in minus 1, I'm going to get a remainder of 11. Okay, find the values of a and b. All right, so we're not doing polynomial division at the moment. We're just going to plug in our roots. 3. 2 minus 20, we know that's a factor, so it must equal 0. Okay, so just watch out for your negative signs here. So this is minus 8. Minus 8 times 6 is minus 48. Okay, 4a minus 2b is equal to 68. I'm just going to divide everything by 2 to simplify it a little bit. I'm going to leave it like that for now. I might make b the subject of my formula. For now, I'm going to just plug in my minus 1. And that remainder is 11. Oh, the remainder is minus 11. Just take note of that. Okay. Okay, so here we have minus 6 plus a minus b is equal to 9. So a minus b is equal to 15. And then I'm going to make b the subject of my formula. So b is equal to a minus 15. Okay, so we'll call this our first equation and that our second one. And what I'm going to do now is I'm going to plug 2 into 1. Okay, so we've got 2a minus, and then instead of saying b, I'm going to plug in what b is equal to. And so here we've got 2a minus a plus 15. And 34 minus 15 is 19. So my a value is 19, and then b is equal to 19 minus 15, which means it is equal to 4. And they said find the values of a and b, so that is going to be 19 and 4. All right, next question, which is connected to this one. So hence, okay, hence means we need to use our above, whatever we did in the above question. Hence, factorize p and determine the exact roots of the equation. And what they're going to do now is they're going to plug 3x into x. Okay, so hence factorize the polynomial. Let's just start by factorizing the polynomial. So our polynomial, if I just rewrite it, 6x to the power of 3 plus 19x squared plus 4x minus 20. Okay, and we know that x plus 2 is a factor. Okay, so sometimes you can do this by inspection, but I'm just going to do polynomial division now. Is it x minus 2? X plus 2 is a factor. Okay, so we know that if we divide our polynomial by x plus 2, we should get 0 as a remainder. Okay, so let's just quickly do that. 6x cubed divided by x squared. 12x squared. Okay, so divide, multiply, subtract. And then bring down. Okay, then we're going to divide again. Sorry, that's not 4, that's 7x. 7x squared plus 14x divide, multiply, subtract. So 4 minus 14 is minus 10x. And then bring down. And then here we have no remainder. Okay, so that's exactly what we're looking for. So when we factorize our polynomial, we know that we can multiply our quotient by our, so yeah, what we divided by, and then what our answer was. If we multiply those two things together, we're going to end up, those two factors bring us back to our original polynomial. So we just need to see if this can be factorized further. Okay, so you might want to use your quadratic formula or just whatever method you know to factorize and just play around and see if there are factors that's going to get you to where you want to be. We have minus 12 plus 5. That seems to work out. So I know I've got x plus 2, and then see. That one has to be plus and minus. X, we've got another x plus 2. So that leaves us with an x plus 2 squared, and then a 6x minus 5. Okay, so just make sure with your factorizing that you do double check. So here, if I cross multiply, I'm going to end up with positive 12. And then here I'm going to end up with negative 5. And when I add those two together, I'm going to end up with positive 7, which is what I want. Okay, and so here we have completely factorized our polynomial. So the trick with this is you always just, whatever you divide by and your answer, the quotient, those two multiply together, and then check if your quotient can be broken up even further. And then this is now fully factorized. Okay, so they say hence factorize and then determine the roots of the equation. And here what we're doing is instead of having just x, we've now got 3x. Okay, so everywhere there's an x, we're now going to have 3x. Okay, so let x equal 3x. So instead of plugging into my polynomial, I'm going to plug it directly into my factored polynomial. Okay, so if I rewrote that, it would be 3x plus 2 squared, and this becomes 18x minus 5. Now, if I was to solve this, because they want to know the roots, I know that 3x plus 2 should be equal to 0, or 18x minus 5 should be equal to 0, and I've got an answer of minus 2 over 3, or 5 over 18. And those are my two answers for that equation. Okay, so the more you get to do these questions, the more you become familiar with the type of questions that they ask you. Right, I'm going to jump right into the next one. I've also got my MF19 here of trigonometry. They say show that, okay, show that, and then we've got a left-hand side and a right-hand side. We're definitely going to be using trig identities. Our notation for that is to start by writing down the left-hand side. So we've got a cosec theta, and then a 3 sine 2 theta, sine 3 theta. Okay, so I'm just writing down my left-hand side, and then I'm going to quickly look at what I'm aiming for. I'm aiming for a cos and a cos squared theta. Okay, so basically all of these need to change. I don't want cosec, I don't want sine 2 theta, and I don't want sine to the power of 3. Okay, so let's just start changing it then. What is not on my MF19 are your basic ratios, where sine theta is 1 over cosec, cos theta is 1 over sec, and tan theta is 1 over cot. Just make sure that you put that also in your long-term memory. We're definitely we're gonna even start using it right away. So cosec is 1 over sine theta, Then I'm going to say 3, and I'm going to expand my double angle formula using my MF19. So my double angle is over here. Sine 2 theta is 2 sine theta cos theta. So equals 2 sine theta cos theta. And I think for now, I'm just going to leave sine cubed because we don't have something for sine cubed. What I'm immediately thinking is I'm probably going to be able to take out a sine somewhere, and then I'm going to have a sine squared, which I'll be able to work with. Okay, so don't just change anything from the get-go. Let's just do one step at a time. Okay, so if I was to simplify, I would still have 1 over sine theta, and then here I've got 6 sine theta cos theta, or sine cubed theta. Okay, I can already see I'm going to have sine cancelling out. So when this gets multiplied into each term, my sines are basically going to cancel. And I'm going to be left with 6 cos theta plus 4 sine squared theta. Okay, so my sines did cancel out, and now immediately I do have identity for sine squared theta. Sine squared theta, if I take my cos to the other side, it's going to give me 1 minus cos squared theta. So I can replace the whole thing. Sine squared multiplied by 1 minus cos squared theta. Okay, does this look at all like what I'm wanting? It does. It is exactly that, actually. I'm just going to rewrite it in the order that they're looking for. And I'm going to say that is identical to my right-hand side. There we go. So sometimes you just have to start even if you're not 100% sure where it's leading to. Okay, now they say solve the equation. They didn't say hence, but can you see that this looks very, very much like what they gave me in the first question? So cos theta, like actually the whole thing is the same. Okay, we just don't have a plus 3 on this side. So what I'm going to do is I'm going to add a plus 3 on this side, which means I'm going to add a plus 3 on the other side because I can't change the sum. Okay, so they want to know that what is the answer to that whole thing, which means if I answer for 6 cos theta, if I answer this, it'll be the same as answering the question that they're looking for. Okay, I'm just going to rewrite this. I can already see this in the format of a quadratic. Okay, plus 4, 7. Okay, might be nice just to make it look a little nicer. So I divided through by my negative, and now I'm just going to use my quadratic formula to solve this. I think you could also do it by factorizing. Okay. Okay, our first answer, oh, it's not so straightforward. Okay, so we've got 2 answers here to our quadratic formula. It isn't so straightforward. Our first one is cos theta is equal to 2.27, and the second one is minus 0.771. Okay, so we've got 2 answers here, and let's just go. We can see our domain is given in radians. This is interesting. Our domain goes from negative pi to naught. Okay, so that's not a very normal domain. Let's just see if we can make sense of that. If we take a look at this, it's also good to just understand what your graphs are. So if I take a look at my cos graph, it looks like that. If I was going in the negative domain, I'm actually only looking for answers on this side. Okay, and they want to know where's the cos graph equal to 2.27. Can you see that there's no solutions? There's not going to be any solutions for this one because the graph does not intersect with 2.27. Okay, if we go from here, so we're looking at our negative and we're looking at about minus 0.77. No, that's probably drawn a bit low. Let's draw it a bit higher. We're going to expect two answers over there. Something like that. Make sure your calculator is in radians. Okay. And we now want cos minus 0.771. First answer. Well, our reference angle is going to be 2.45. Okay, if I was just to look what angle did the calculator give me, it's given me that angle over there. So can you see that just because of symmetry, it's going to be my negative angle. All right, and then how do I get to this one over here? Okay, so if I get that angle, it's going to be minus 3. No. Ooh, why is this confusing me? Okay, if I take this angle and I subtract a full 360, I'll get to that angle. Okay, so theta is also equal to 2.45 minus, and it's not 360, it's minus 2 pi. So 2.25 minus 2 pi, that gives me a negative 3.831, but they only wanted me to go up to pi, not to minus 2 pi. So therefore, my theta is minus 2.45 only. So this is outside of the domain. Outside domain. And this is outside domain. When I drew my graph, I shouldn't actually have drawn the full 360 curve. So this should have stopped somewhere over there, and I didn't need to even draw any of this. So we would have gotten one answer over there, and that is my minus 2.45 radians only. Okay, so always just check your domain at the end of the day with regards to each of these questions. Okay, we can jump into our last part of this question. And here we've got integration, and I've also just put the integration section of the MF19 into this. So they say find the integral of, and then they've got all of this trig stuff, and what you can see is this the same as what we had in part A. Right, so always take a look at these questions, what is the same as part A and what's not, and generally you'll find that it's easier to integrate part A than part B. So here we can see it's exactly the same thing, cosec theta, and then we have 3 sine 2 theta and 4 sine cubed. So what I'm going to do instead is I'm going to work out the integral of, and then I'm going to look at this other part. 4 plus 6 cos theta minus 4 cos squared theta. Okay, minus 4 cos squared theta, and then we're going to be integrating in terms of theta. All right, so if you're familiar with your work, you will know you are able to integrate 4. We're able to integrate cos, but we're not able to integrate cos squared theta. So that first needs to be changed into, we're going to use our identity. I'm actually just going to copy this part of my MF19 as well. We need to change this into a double angle. Right, so if I take a look down here, I can see that cos 2 theta, I'm just going to write it on the side, so cos of 2 theta is equal to 2 cos squared theta minus 1. And what I'm going to do is I'm going to make this, if I change this up here, you can do this in different ways. Okay, what I'm going to do is I'm going to change my 2 cos squared theta, because in this identity here I already have a 2 cos squared theta. So I'm going to say 2 cos squared theta is equal to cos of 2 theta plus 1. Okay, so I like to do that just somewhere on the side as I'm preparing my integral. And so I'm changing that exact part, so it's cos of 2 theta plus 1. And all of that is in terms of theta. And just to simplify this a little bit further, minus 2 cos 2 theta, and then minus 2. Okay, I'm done with this now. I'm just going to delete that. So now I've got the integral of 2 plus 6 cos theta minus 2 cos of 2 theta. Now each of these terms I can integrate. So if we just use our integration rules, and all they wanted me to is to find it. So this is an indefinite integral. I'm going to have my plus c at the end. So here we're integrating 2, so that just gets a theta. Then cos theta, the integral of cos theta is just sine theta. So that becomes 6 sine theta. And here I'm going to keep my coefficient. Cos becomes sine. So this time it's sine 2 theta, but then I need to divide by 2 because I have a composite function. Sine theta minus sine of 2 theta. I should have also put my plus c up at the top. So I've got a plus c then at the end. And that is my integral for this question. Okay, we're going to jump into our final question. It's got the part A to D. And I can see some implicit differentiation here. So we see there's a curve with that equation, and it has a stationary point at PQ. So dy dx at x is equal to P is going to be 0. So wherever there's a stationary point, our gradient find the exact value of. Right, so they want an exact value, so no decimals. So we need to keep our e's most likely. And then what you see here is we've got x's and y's mixed up in our equation, which means we need to be using implicit differentiation. Okay, so when we do implicit differentiation, we just start differentiating. And every time we differentiate a y, we're going to add dy dx. Or more like, we'll multiply by dy dx. So here we have e, the derivative of e to the 2x is e to the 2x, not times a half, times 2, minus 18. And here we're differentiating y, so it's 3y squared. And then we need to add, multiply it by dy dx. And then if we just differentiate y, it's kind of like 1 dy dx. And then differentiating the 11 becomes 0. All right. So we could technically, okay, wait, let's just see our derivative. We know that our derivative is going to equal 0. Let's just first work out what is our derivative equation. That's going to be the easiest. So all my terms that have a dy dx, I'm going to keep on the one side. And I'm going to take all my other terms to the other side. Okay, I'm going to take out a dy dx. And I'm going to be left with dy dx is 18 minus 2e to the 2x over 3y plus 1. Okay, so here I have my derivative. And now I know dy dx is equal to 0 at a stationary point. So in other words, 18 minus 2e to the 2x is equal to 0. So my denominator is never going to be 0, or if I want, I could write it, but then as soon as I multiply it to the other side, it falls away. So I'm just going to leave it. So I know 2e to the 2x is equal to 18. And here we need to use our ln or our log laws. Ln 9 over 2. If we were to get an exact value, and they did ask for the exact value of p, I know that this is a half ln 9, and if I take up my half, I'm going to end up with ln 3. Okay, and that is our value for p. All right. Now let's keep going. Show that Q is equal to this whole thing. All right, so what is Q? Q is the other point of our stationary point. That's the y coordinate of our stationary point. All right, so we know what P is. And now we need to find Q. So what we've got to do is we've got to go back to our original equation, because that's a relationship between x's and y's. So e to the 2x, I'm just going to write it down, minus 18x plus y cubed plus y is equal to 11. I think that's what it was. Okay, and we know that x is equal to ln 3. So I'm going to plug ln 3 into all my x's, and then I'm going to manipulate it to look like the above formula. Okay, so e to the 2 ln 3 minus 18 times ln 3. My y value at this point is going to be q. Right? What I can see here, you always want to look at what you're aiming for. I can see a cubed root, so I'm probably going to make this q the subject of my formula. Okay, so let's start. I'm going to start taking all my other terms to the other side, or I'm actually first going to simplify this a bit. So e, and then I'm going to say ln of 9, because I'm going to take my 2 up to the top there, and then it's going to become 3 squared. Okay, minus 18 ln 3. I'm leaving it like that because I can see I've got something like that over there. Plus q to the power of 3 plus q is equal to 11. Now I'm going to make q to the power of 3 the subject of my formula. Okay, what I can see here is these two things fall away and my 9 is like going to drop. So that's just a 9. And I can see 11, if I take my 9 to the other side, it's going to become 2. So 11 minus 9 is 2. My negative becomes positive, 18 ln 3 minus q, and then I need to just cube root all that. Right, so what I find helpful in these types of questions, always look at what you're aiming for and which q is the subject of the formula. Sometimes it's obvious, sometimes it's not so obvious. Also, just start from the basics. We know what our x value is, and we're looking for our y value. That's why I started with my original equation and I plugged in my x at that point. Okay, now they say show by calculation that the value lies between 2.5 and 3. Okay, so what we do is we get all of our terms to the one side. I'm going to take one all to the left. Let's just say that is equal to 0. So if now I'm going to plug in my 2.5, all my q values, and that is going to give me an answer. So 2.5 minus the cube root of Then 3 minus 2.5. That gives me minus 18, minus 0.18 rather. Okay, and if I plug in 3, okay, so I'm just going to go back onto my calculator and I'm just going to replace all my 2.5s with a 3. And my answer is 0.34, and so what we see here is a sign change. So we know that the value is between there and there. Okay, now it says use the iterative formula based on B. Okay, so we're going to go back to our formula over here. So we know Q okay, so we want to try find Q now. We need to give 4 significant figures for our answer. And the results must be, each result must be given to 6 significant figures in between. So you can start with either 2.5 or 3. I'm going to say it's 2.5. And so all we're doing is we're just plugging our values into this equation, and we're going to wait until what we put in is the same as what comes out, basically. Okay, so if I do that, I get an answer of 2.6812. So 1, 2, 3, 4, 5, 6. So 6 significant figures. Okay, I'm now going back and I'm plugging in my answer button. Q3 is 2.67279. Just make sure you give 6 significant figures each time. 7, 9, 1, 2, 3, 4, 5, 6. Ooh, 7, 1, 2, 6. Okay, so I've just given 7 there instead of 6. Okay, and what we want to see is we don't want it to change. Our first 4 significant figures needs to stay the same, then we know that we've kind of got the right answer. Okay, and it looks like I am rounding off too soon here. 1, 2, 3, 4, 5, 6. Okay, and my next one is the same, and the next one is the same. So I just click equals a couple of times. Therefore, I know that my answer is 2.6732. 1, 2, 3, 4. Oh, more than, there we go, 673. That is 4 significant figures. And that is my answer. And there you have it. That is our October-November 2023 paper 2-1. For Pure Maths 2. I hope that was helpful. Thank you.